Okay, let me do that. Nice. We're gonna get started. Just before we do, here's some opportunities that ASME is having. First is the social with PSP, and the second one is the DEI scholarship. It basically asks you to write like 250 to like 500 word responses for a chance to win $500. Highly recommend you guys to take part in it. QR code's here, and it is also in the ASME Slack if you guys miss it. Besides that, we're gonna get along. That's the attendance form. If you guys want to scan it, it's also in the Slack chat. Bernardo just posted it there. So today's gonna be a bit different because Bernardo's not gonna be here with us. Jordan, our chief engineer, is actually gonna come and assist me today. So I'll be taking over this one, and Jordan will be here shortly. So yeah, I'm gonna give you guys about like 2 minutes. Hello, hello, hello. Okay. Sorry, I was checking my mic. Sorry. Could you guys give me a thumbs up if you're done with the attendance? Cool, cool. All right. If you guys missed the attendance form or the QR code, it'll be in on Slack and on the email that we'll be sending out. So we're gonna move on. First thing I want you guys to do is open the Fusion file that Bernardo sent through email, which should be called analysis. Once you guys are done with that, could you guys also give me a thumbs up? So cool, cool. Thank you, thank you. Thank you. Yes. Okay. Okay. Could you Alrighty, I'm assuming everyone's able to open their file. I'm just gonna go on. So next thing we want to do is make sure your units is set to millimeters. Uh, I'm gonna go here just to show you guys if you don't know how to do that. You basically go to document settings and here's units. Okay. So again, there's the drop down here for document settings. You're gonna click that. Here's units, and usually it's in inches. You just want to convert that to millimeters. That's fine. You know what? Yeah. Let me know if you guys have any questions, by the way. Anytime, just raise your hand. Yeah. Are you guys able to do that? Yeah. Cool. All right. Keep going here. Okay. So now we're gonna analyze the model. Just by looking at the model, could you guys guess like why it's not like a very optimized model? Like, if you guys look at the model, do you guys think there's any weak zones within the model? Okay, and okay, so turns out there is actually weak parts like within the model, weak zone, sorry, and that's all the edges slash sharp corners that are in the model. And why is that? Is because stress concentration usually builds up like around sharp corners, and what designers usually do is they add fillets to it to more evenly distribute the stress. So if you guys, sorry, you let me just move on here. Yeah, so if you guys unsuppress these features, you guys can see what actually happens to your model, like what an quote unquote optimized model would look like, where and I'm going to show you guys how to okay, I'm gonna show you guys how exactly to unsuppress. If you guys don't know, you just right click on these sort of like shaded icons here. You right click and there should be an unsuppress features. Click that, and then same thing with these over here. Click that unsuppress. Uh, okay. So yeah, so what influence do you guys say? Well, obviously by unsuppressing those features, and if you guys see here, one of them actually gets rid of a like from the center here, you can see it actually like negatively extruded from the part, and that's because as we will see, this part alone has a very high safety factor, really high to the point where Fusion's like, hey, you don't need this much like material. You don't need like this to be completely filled. Like we could have a hole and save some material, save cost in turn, and like the part would work just fine for what it's supposed to do. That's the main purpose. So now that we know like we have our part, we're actually gonna start with FEA. It's exciting now. So first thing we want to do is switch from design to simulation. So when you guys are using Fusion for CAD, you guys are always on design here. So here in FEA, we don't really touch on design. We go down here to simulation, and you guys can see like a color gradient close to what Bernardo presented last week. Click on that, and so again, it's just up here, design, and over here, simulation. Click on that. Shoot. Okay, sorry, let me go back here just because I have to unsuppress something. Press that. All right. Cool. Yes, don't mind the warnings here, but you guys should see not this screen actually. Let's just create a new study. You guys would see something like that. So for this FEA course, we are just going to be focusing on simplify, static stress, and shape optimization. But simplify and shape optimization, we're going to start like later in the weeks. Yeah, but then you guys can see there's a lot of different ones. We're not going to touch on any of these, but the basic one is static stress. Basically, if you know how to set up a static stress analysis, you guys are on a good track to set up other types of studies here. So we're gonna create a static stress here. Click on that. Yes. Thank you. All right, we're gonna go back here. And yeah, this is what I told you guys. This is what the simplify does. So I'm gonna go back here. Uh, Here you guys can see simplify right next to the study. I'm just gonna explore that for now. And you guys can see like a very similar sort of screen to what you would have when you're in design here. So I'm just gonna try something out here. I'm just gonna create, say, a rectangle down here. Just finish sketch and extrude that negatively. So now we have a hole here. One thing to note about simplify is actually when you finish simplifying here and you go back to your design, this is not gonna be there. This hole is not gonna be on your original design. Its main purpose is just for you to sort of um, edit your part a bit and change up your simulation or study. So I'm not actually gonna do that. So okay, we're back here. And yeah, so there, it's just to temporarily modify your model. And when you guys go back to your design tab here, really like you're not gonna see the change. So next, so the next thing we'd like to do usually when creating a study is to apply our materials. And to do that, we go to the check study material section. Right now, you're at same as model. Now we'd like to change that. So I'm going to show you guys how to do that. First, just drop down here. We'll need to go to study materials here again. So yeah, you'll be here. Click that arrow. You'll see study materials. Two ways you can edit it is through the pencil here, or you guys can see here. You guys just right click, basically study materials, and you guys are the same as model. Now for our studies, we'd like you guys to change it to aluminum. So sorry, I have like a bunch of them. I was like trying out how to create custom materials, so don't mind that. But you guys should have like one aluminum. Just pick that and click OK. And now your study material should be set. You guys have any questions up until now? Cool. All right, I'm gonna go back. Next thing is your safety factor. So this includes a lot of like engineering properties that I don't really. I mean, it's important. Don't get me wrong. Let's just not. Give me a sec. I forgot how to get here. It's in see materials. Yes, here. Yeah. Okay. Here. Nice. Yeah. So that's how you look at your different properties for the materials you pick. Uh, we're not really gonna take into like we're not gonna take any of these into account. All we know is we're gonna use aluminum. So that's all you guys need to know. Once you guys are done with that, let's move on. So the next step of creating a static stress analysis is to apply your constraints. Because I mean, at this point now, what Fusion sees, this part is floating in space. Like let's take this grid out. It's just floating in space. Fusion doesn't know what to do with it. So tell Fusion what to do. First thing is constraints. Up here is the constraints tab. And we click, there's a lot of different ones. Just gonna go the basic one. You can just click on that. And we're gonna use a fixed constraint. There's a lot of different ones you could pick from. But we're just gonna use fixed because it's the most simple one. And we are going to fix this inner hole here. So what this is telling Fusion here, you can see I have all three axes selected. This is telling Fusion I want this inner hole to be fixed with respect to, let's see, there you go. With respect to the X, Y, and Z axis. I don't want this inner hole to move at all, right? That gives the foundation for our static stress analysis. So I'm going to hit OK there. I'm just going to hide the origin. So far, everybody good? Yeah? Cool. Yes. Yes. Alrighty. So next thing you want to do usually is apply your loads to your models. And for this one, we are going to apply a force load. So select the structural load. So and then yeah, select force from the drop down. You want to select the interface of the smaller hole. And it's a lot of different things. So I'm just gonna go through this first. So we're going to edit our angle, our direction type, and we're gonna set a magnitude. So I'm gonna sort of give you guys demonstration on how to do that. Now that we've made our constraints, next thing we want to do is your loads, which is up here, right next to constraints. Click on that. So again, on the drop down, there's a lot of different loads you guys can pick. We are going to stick with force for this one. Now it's asking us for a target. Earlier, we constrained our inner, like our big hole. Now we're going to apply our load on our smaller hole here, right here. Now you don't want to click here or here. Click on the face, the inner face of the hole. Click that. Now there's a lot of different things we could change here. We could change the angles, change the direction reference with the direction of the arrows, or we could change the magnitude of our force. We want it to be 1,000, so you guys can set it at 1,000 newtons. Oh, where's this not working? There you go. 1,000 newtons. So if you guys aren't seeing newtons right now, if you guys are seeing pound force, that's probably because you guys forgot to change your units, your dimensions. But is everyone good? Is everyone seeing newtons here? Yeah, cool. Another thing you could change is your angle. Of course, in the X, Y, and Z direction. You guys can change it here, of course. To me, that's kind of boring. I just like to drag these around, and it tells you like the angle right here. So you want to change it to 180 degrees, or in other words, you want your arrow pointing the other way, pointing out. So usually Fusion does it differently for people, which is kind of weird. So if your arrow is already pointing out without you changing your angle, just leave it at that. Everybody good? Cool. I'm gonna go back here. So next thing we want to do for FEA static stress analysis is to generate the mesh. So earlier last week, Bernardo talked a bit about meshing, and we're gonna get a lot deeper into it next week. But right now, we are just going to create a very basic mesh here. And here is sort of a very general, general like step by step on how we can edit the mesh. First we want to go. Okay, I have a question for you guys. Do you guys prefer if I like read it from here and you guys do it yourselves, or if I'm over here and I sort of just like talk about how to step things up? The latter one? Cool. All right. So there's a lot of different ways that you guys can get to your mesh. First one's over here. Second one's over here. Third one is over here. It's over here at settings. All right, I'm gonna go through each and every one of them. First one, you could go here in our drop down. So if you guys are seeing this right now, click this arrow, gets you to this drop down, and you should have mesh right here. And then you want to go to edit here. And now you guys are at this mesh page, right? So we're gonna get a lot deeper into this and like what each of them means. But as of right now, I want you guys to make sure you guys are at model base size and at 10%. Now, how do you guys know if you guys are at 10%? You guys just hover over this arrow. If you hover over it long enough, it tells you what percentage you guys are in. So that's the first way. I'm gonna hit X here. Next way you guys can do things is actually not here, sorry. You go to settings, and at settings here, below general is mesh, and it's exactly the same interface we saw earlier. Doesn't really matter how you guys get to this mesh setting. As long as you guys know how to get there, you guys are fine. So go here, click OK. That's one way you guys can do it. Another way, if you guys don't really care about your mesh, you guys can hit this I, toggle this I, and it's gonna tell you that it's not been computed yet. Just hit yes. Fusion's gonna put like a generally rough, simple mesh. So this is what it looks like. Is this what everyone is seeing right now? Cool. So we're gonna go next. One thing I want to mention is Fusion has a tool that can help you guys out a lot in like seeing whether or not you guys set up your studies right, and that's called the pre-check tool. And basically what it looks like when you guys are ready, when you guys set things up right, you'll see a green check there. If you guys set things wrong, you'll see a red error here, and I'm going to show you what that looks like. The one over here, pre-check, is right next to solve, right next to settings over here. And if I click this now, you guys can see, I mean, from here, we can already see it's green. There's a check here. I've set everything up. Fusion's telling me, all right, we're ready to solve, but I'm just going to delete something here. See, if I take that constraint out, Fusion's not very happy with me now. It's telling me, hey, like, I don't understand what you want me to do. Like, yes, there's a load, but there's nothing fixing it to the ground, right? If I apply that load, our model's just gonna move along with it, right? So that's basically what Fusion is telling us. And depending on what you forgot, Fusion will give you a different warning. So I'm just gonna apply that constraint back here. Again, there you go. Fusion's like, all right, you're ready. So that's that. Okay, so now we're going to actually get into solving our model. So right next to pre-check is the solve. You click on that and click on your study. So you guys shouldn't be seeing like any of the other ones. Just you guys should be seeing something like this. And you guys just hit solve one study like that. And it could take like 2 to how many ever minutes you might need Fusion to run the study. And in the coming weeks, we'll realize that the speed at which Fusion is solving these is completely based off your mesh. So right now we have a generally rough mesh, so it shouldn't take Fusion that long. But as we get to smaller and more defined meshes, Fusion will take a lot longer to solve the studies, but we don't have to worry about that for now. Yes. Up to this point, anybody have any questions? Yes. Okay. Oh, one thing. So while we're doing that, let's see here. Give me a sec. I don't know. Okay. I'll figure it out. So there's a way. So by week 3, you guys have to switch your account to something within Fusion. It's fairly simple. I don't remember how to do it at the top of my head, but I'll be ready with it next week. So yeah. Yes. Yeah, for sure. So I'm just gonna, so this one's solving right now. So I'm gonna go to this one over here. Yes. After pre-check. So once you're done with your mesh, give me a sec. I'm just gonna update my mesh here. Cool. Okay. After pre-check. Yeah, so when you're if you have a green already, if you see that your pre-checks a green tick mark here, that means you're all set for the next step of the FEA analysis, which is to actually solve this study. So that's exactly what we did earlier. We hit solve and we just solved it. Another way you guys can get to solve is through here, simulations. You guys can right click and there should be solve down here. But that's very like that's hidden, right? I mean, this is way bigger. It's way easier. I mean, it has like solve right under it, so that's probably the easier way to do things. Just to go here and hit solve. But yeah, I mean, by this point, it's a waiting game. Just waiting for your studies to finish. So I'm gonna go back here. One more thing while we're waiting, we can change the names of our studies by double clicking here. And I'm just gonna call it 1000 units again. Cool. All right. So as you will see, once your study is done, you will see this status is complete and you'll see a results detail here. First thing you guys will see is, let me make this bigger actually, because cool. Yeah, a lot better. First thing we have is the safety factor. So there it says actual minimum safety factor of 15. Now earlier last week in Bernardo, we talked about how in industry, they usually look for a safety factor of 1.5. And a safety factor below 1 means that whatever stress or force you guys are applying on your model, if you're actually going to do that in real life, your model's going to break. So a safety factor of 1.5 means that your model can sustain whatever stress or force you guys are applying on it. Next thing is actually Fusion has some recommendations. Very general recommendations, but nevertheless good recommendations. First one you guys can see is use shape optimization to remove unnecessary material. We're actually gonna get to that in week 4, and we're gonna ask you guys to do shape optimization on your final project. So, yeah. And the second one is to try testing weaker, less expensive materials. So if we wanted to, we could switch over to like cheaper, less durable metals or plastic, but we're not going to do that. But by this point, has anybody's studies finished, or is yours is done? Damn. All right. Cool. All right. Um, Yeah, so once it's done, I'm just gonna go over these slides, and once the study's done running, I'm gonna go back to Fusion and show you guys what exactly each of these are saying. Okay. So, yes, that is all. So once your study is actually done running, there's a lot of things you could do with it. First things first is you guys can choose what you want to visualize. So there's a lot of different factors you guys can actually pick from displacement, safety factor, as well as stress. So you guys can see how each component is, affecting your model. And the next thing that Fusion allows you to do is sort of observe the deformation of your model as it goes through that stress. And there's 3 modes. First is undeformed, which is basically what your model looks like before you apply the stresses on it. Second one is actual, and third one's adjusted. Now, by default, when these studies are done running, the results you guys are gonna see are adjusted. And this is just because, say, the study we just did earlier is a force of 1000 newtons, which might not be a lot on our model itself. So the actual displacement could be like times 10 to the negative 4 millimeters. So it's really small. And if we keep it at actual, we might not be able to see the deformation at all. So that's why people usually use adjusted, just to sort of give them an idea of how their model would deform. Um, but yeah, I'm gonna go back to Fusion to see if it's done. Mine's done, so I can show you guys what it looks like. Cool. Nice. So this is sort of like the screen you guys would have. Yeah. So this is the screen you guys would be introduced with once your study is done running. So as I mentioned earlier here, the minimum safety factor, 15, is really high, unnecessarily high even. And yep, these are the recommendations like we saw earlier. So I'm gonna skip over those, close that. And here's what I'm talking about. There's a lot of different results that you guys can pick from. Safety factor, stress displacement, For this course, we're going to be focusing on three main ones, which are safety factor, stress, and displacement. Just those three. Just those three. I mean, like you guys can explore reaction force, strain, contact force, but we're not going to ask you guys to do anything with those. We're just going to ask you guys for screenshots of the safety factor, the stress, and the displacement. And like I mentioned earlier, here's the deformation. We have undeformed, actual, and adjusted. Now, as I mentioned earlier, it defaults to adjusted. As you guys can see, let's go to stress actually. Yeah, that's better. It looks like our part actually moved a lot, right? Like if we go here, we can actually see it's a very small displacement. It's a very small displacement. If we go to actual here, we can barely tell the difference. We have to zoom in like a lot. There, that's our displacement. That's why we use the adjusted because like I mean honestly we wouldn't be able to tell if we kept it at actual and we just looked at it like that, like you wouldn't be able to tell our model's deforming at all. So if we want to get an idea of like if we were to increase the force applied, how would our model deform? That's one of the main purposes of adjusted. Another thing you could do is animate how your model is deforming. So that's something pretty cool, I think. So yeah, three things: displacement, stress, and safety factor. When you're on stress, by the way, in this course, we're going to focus on von Mises stress and keep your units as megapascals. Any questions? Is everyone at the same screen I'm on? Yeah, cool. Oops. I'm gonna go back. Oh, by the way, if you guys are logged out from your results, like I am here, you guys can easily go back using this one, this button over here, the results. Just click that and you're back here. So yeah, we're done with that. Next thing we're gonna get to is the oh, I forgot this. Yes, okay. Yeah, this is another thing we could play around with. The inspect. I don't really go through these. But yeah, so if you guys are tired of like looking at these, you can just hide those. And then if you guys want to look at how a specific point within your part sort of is affected by the stress and how it deforms, you guys can put a point probe here. And the last one is reactions. I don't really, we're not going to get into. So yes, that is all I might. Okay. Yeah. So that is all for me. What we want you guys to do now is change the values yourself, make your own studies. So we're gonna create 4 different studies now. And if you guys created that 1000 Newton one, that's one study. You just have to make 3 more. But before we get into it, I want to show you guys an example submission of how we expect you guys to submit your work. Just give me a sec. I'm gonna share a document. Cool. And if you guys are having trouble remembering what the first steps are, I'm going to show you guys how to set up a study one more time. So don't worry about that. Let me just show you guys how we would like you guys to submit your work. Alrighty. Let me make sure I'm still screen sharing. Cool. All right. So this is how, well, it's like a rough, yes, it's just like a rough estimate of what we expect from you guys. So this is what we want you guys to have. A screenshot of your displacement. And we want the entire screen, by the way. So displacement, the stress, and the safety factor. So those 3 components. And since you guys are doing 4 studies, we're asking for 12. So 3 from each study. Okay. Here's some ways we don't want you guys to do it. So the issue here is, I mean, you could have asked someone else who took this course to send you guys the screenshots, which I don't know why anyone would do. But per milestones instructions, they would like the entire screen where they could see the dates, see the times, and see like your entire screen basically. So this is one way we don't want you guys to do it. So another way we don't want you guys to do it is, again, there is another thing is we'd like to see the minimum and maximum values. So please do not hit that. Just show, don't hide it. Just show it. Like we don't mind. We want to see it actually. Um, and the third one again, no timestamp. So something crucial is we'd like to see the date and time so we can actually like see you guys. You guys are the ones that did it. Um, so yeah. If it's not, I think it's shared already, but if it's not, I'm gonna include it like in Slack or in the email being sent out. So don't worry about that. But besides that, I feel like we're good. Do you guys have any questions? The maximum stress value? Oh, sorry. Here. It could differ slightly. We're not asking for a pinpoint accuracy. Like the biggest part of this course is we want to see that you guys are able to create your own studies. We want to see that you guys are able to show us stress, safety factor, and displacement. That's sort of like the biggest target we have within this course. So if you guys can do that already, you guys should be in prime condition. So yeah, I'm gonna make this full screen so you guys can have a better look at yes. All right, cool. Yeah, so first one we're asking for is the 1000 newtons, which we just did. Second one is the 5000 newtons, and third one is 10,000 newtons. Now, this fourth one, we're asking you to create a new study. So this is four separate studies, and we want you to edit this 10,000 newtons one, 10,000 newtons one, and add another angle to it. This time in the y-axis. So I'm going to show you guys how to do that. Um, something helpful to you guys is instead of creating a new study, reconstraining it, putting new loads to it, one thing you guys can do is right-clicking here and clone study. I'm sorry, much better. Okay. Instead of like hitting this and like creating a new study and then reconstraining it, adding new loads to it, what you guys can do is right click here and clone study. This makes things a lot quicker because when you clone study here, just gonna close that. Of course, you need to generate your mesh again, but why it's better, I think, like personally for me, is because you have your constraint there. And if you just want to edit like the magnitude of your load, you guys can do that. So adding 10,000 is as easy as that. Now, again, the fourth one asks you to change your angle to 90 degrees. So we just want to change this to 90, which is basically an arrow pointing down, right? Again, Fusion might like put your arrows in default in weird conditions. So the main idea is we want your arrow to be pointing down. If you guys have that and you guys are at like 90 degrees, like we don't mind, right? That's just the main point. We just want it to be like pointing down. So yeah, I'm gonna go through how to create a study one more time, and then you guys should be good. I'll walk around if you guys have any questions. So you want to hit study here? Oh, let's go from the beginning actually. So we start design here. This is the normal Fusion interface you guys are probably used to. Up here, you go from design down to simulation. And when you're there, you you probably won't see the screen. You'll probably see a screen like this that's asking you like, all right, welcome to simulation. Like, what do you want to do? And for this, we're going to use static stress. You can double click on that or click the simple the create study. I simply double clicked earlier. One thing you guys can do again, double click and change your study. Um, and then first thing you want to do is your materials. By default, it's going to be same as model, which is steel. We actually want to change this now to aluminum, right? That's the material we're going to use for the rest of the course. Okay. Next thing you want to do is add constraints to your model. For this class, we're gonna follow 3 weeks. In the weeks to come, we're gonna have the exact same constraints and loads. So try not to get bored. So we want to constrain the inner circle here, the whole of the inner circle, not not the edge, but the face inside. And you want to make sure that all 3 axes are highlighted and your structural constraint is at fixed. Once this looks right, you're gonna hit OK, and you guys should see a lock mark here. That's how you know if you did it right, and if there's a lock mark. If you have a Y, if you have any axis basically that's not highlighted, it's gonna be an unlock mark, which is Fusion trying to tell you like, hey, our part can still move. A lock mark basically tells us that, all right, our model's fixed now. We're ready for the loads, and you guys can find loads right over here on top. Just click on that. A lot of different types of loads to go over. Specifically, we're going to go with force for this course. We're going to hit the inner face of the smaller circle now. Again, not the edge, the inner face. Now the arrow's pointing towards the lock. We wanted to point the other way. 2 ways we could do that is edit the angle here, 180, or you could rotate by dragging on this. Sorry, again, 180. That's good. Or what you could do as well is hit direction, right? Again, either way works. And then that's how you set up your magnitude. You could input here or here, doesn't really matter. We're gonna hit OK. And then next thing you want to do is generate your mesh. Again, 2 different ways. You want to hit the pencil icon here to edit your mesh, or you go up here to your settings and go to mesh. Right? Either way is fine. You want to make sure your mesh is a model base size at 10% for this week. I'm gonna hit OK. Once you've done all that, you guys should see a green check here. This is your pre-check telling you you're ready to go. If you guys do not have a green check, you guys can review in the recording what you guys did wrong, or if you guys are here in person, you guys can raise your hands. But once you're done with that, you guys should be ready to go. 2 ways you can solve. Hit the solve here. Fusion will automatically select whichever study you guys are on right now. But I have other studies here, and you could actually select multiple studies to create to solve your studies simultaneously. We're gonna get to that next week. But you basically hit solve 1 study or however many studies, and you guys wait. And then once you guys are done with your studies, this should be the screen that you guys are. No. All right, I think this is good. Cool. So once you guys are done, like once your studies are done, this is sort of the screen that you'll be introduced with. And give me a sec here. There's one thing I want to see. It's not here. Is it here? Nope. But yeah, basically we want you to screenshot this. So this is one good screenshot, the entire screen. And then go down to stress, screenshot, and switch over to displacement. That's 3 screenshots. You have 4 studies. Do that again 3 more times. Compile that in a Word document and submit it to us. Do you guys have any questions? Yes. Okay, Jordan will be out to help you. Okay, so I'm just gonna go back here, because yeah, and just let me know if you guys need any help. Sorry. Yeah. So again, 1,000 newtons, that's 1. 5,000, that's 1. 10,000, that's 1. And then 10,000 plus the 90-degree angle at the y-axis, that's another 1. Total of 4. three screenshots each. Okay. Yes. That's completely up to you guys. It's a lot more simple if it's suppressed, but if you guys wanna, try it out for yourselves, we're not stopping you. Yeah. So it's your choice, basically. Yes. Oh, yeah. Yeah. Okay, that should be fine. Um, so let me go back here. So, if you're on simulation right now, I'm sorry, we want you to go back to design. Uh, yeah. Let me know if you're already in the screen. Yeah. Okay. Cool. Sorry, I'm gonna keep you over here. You want to right click on this. It should be like there should be some that seem to be shaded, like this fillet features over here, this extrude, and another fillet. These are all shaded. To unsuppress them, you want to right click on any of them, and then third from the bottom should be unsuppressed features. Do you see that? Oh, okay. Yes. Did you have a question earlier? Okay. You guys all good? Yes. Yeah. It's oh yeah. Okay. Actually, let me get a bit more into detail with that because there's a lot of different errors you guys we could get. Sorry, how do I do that? Yeah, yeah, go back there. Nice. Okay. So right now it's at green, right? So we're ready to solve. Like we've set our study up, right? One error we could have is by deleting the constraint. And now if we take this grid off, there's nothing like holding our model down to the ground. So applying this load that basically pushes it, nothing's gonna happen, right? Our model's just gonna get pushed along and like there's nothing happening. So that's the first one. Fusion's telling us like, hey, there's no structural constraint here. Like we can't analyze anything, nothing's gonna happen. Our part's just gonna move. So that's the first one. Second one is if we delete this. How do I delete this? Make this 0. Can't do that. So how about that? Oh, I forgot. Sorry. So if you guys want to delete your loads, it's over here. I'm gonna suppress it. This is another type of error you guys can get. There. So there's no load. Fusion's telling us like, yes, our part's fixed to the ground now, but nothing's happening to it again. So there's nothing to analyze here. Another type of error you guys can get is, I don't know if it works. Yes, okay. So there's a lot of different materials within the Fusion library. You guys can see some of them have warnings next to them. A lot of these are non-linear material, like a lot of wood, right? If we try to pick a wood, let's say we go for a cherry, hit OK here. Fusion's gonna hit us with another error, telling us like, hey, we can't analyze wood because it's non-linear. Um, so that's three of the different errors you guys can get. There's a lot more, but those are the most common ones. Yes. Yeah, for sure. Uh, Let me just change my material back to aluminum. Cool. So mesh, there's two ways you could go about it. First is right here. Hover over that and a pencil icon should appear. Click edit. That brings you here. Another way you guys can do it is go up to settings and right below general is mesh. Same exact interface, same exact thing you guys will be seeing. And we will be exploring the advanced settings next week. But as of right now, again, we just want to keep the 10% model-based size and hover over the arrow. That's how you guys can see what value you guys are at. one thing I want to show you guys is why exactly I have these out of date results. So if we change something within our design here, say I unsuppress this feature here. If I go back to simulation over here, sorry, give me a sec. See, let me save this. Cool. Yes. There you go. If I go to simulation, oh, sorry. Yes. Um, it will say that wait, it's out of date. So every time you guys see a warning here, it's basically Fusion telling you that you did something to the part, and now like we have to Fusion has to run the tests again in order to get an accurate result. So if I generate this mesh, and let's see if we can go back to results actually. Yes. So because we changed the part now, like if you initially had this feature suppressed and you guys decided to unsuppress it and go back and try to view your results, Fusion's gonna hit you with this error saying, like, yeah, we haven't done this yet, even though you might have ran the study earlier. And that's because you unsuppressed this material, and now it's a whole different model, right? Fusion has to run it again because it has to take into account this hole now. But yeah, that's one reason why you would have a warning here, like I do. Yeah. That's completely up to you guys. I mean, if you guys did the 1000 newtons without it, without it, basically without this being unsuppressed, then if you guys want to go along with it, we don't mind. Like it's completely up to you guys. Sorry. Yes. For this week, we're gonna ask you guys to stick with 1000, 5000, and 10,000. Oh, yes, most definitely. Yeah. But for this one, we're just gonna ask you guys for one. But most definitely, like if you guys are just doing your own studies, you guys can have more than one courses. Yes. Mhm. Oh, okay. Let's try that out. Create a new study here. Did you have the first load here? As usual? Cool. Whatever. Oh, I see. Did you try it again, like over here? I believe it should work if we go on any other part. Like, let's say we have another load here. That's 100. We should have. If you guys can see here, um, there's a lot more arrows on this new load that I put than there is here. By default, it's usually a distributed load that Fusion applies. That's why there's a lot of arrows here. It's just telling us like, hey, we're applying this load like in all these areas. There's a lot more, but it's just a general overview. That's basically how Fusion does things. Um, yeah, I'm gonna go back here and actually, if you guys can give me a second, I'm just gonna stop the recording.